Okay, guys, let us get back to the topic. So they will be joining in the middle. So here, what we are discussing. So what is the topic that we need to cover here, and what we are going to see in this, whatever the topics that we are going to follow through. So in the last session, we discussed about the physical computing, and then we have discussed about the virtual machines. So these are the two topics that we have covered. So the main problem with the physical and virtual machines, we have discussed about these. So there are a lot of cons rather than the pros. Of course, there are some advantages with the physical servers also. Physical servers are what I can say highly responsive for the user requests, okay, compared to the remaining virtual machines and the Docker application. Now, the point is when we are working with the virtual machines and the Docker, if you see virtual machines uses the physical layer of your server. So what is the meaning of this? For example, so here you will have your hardware, you will have the hardware. On the hardware, you can create a virtualized of using, you can use your VMs, and on the VMs you can run the application. This is what the strategy that they are following. So, but the problem here is whatever the virtual machines that you are running, for example, if you think this is the virtual machine, so this virtual machine will not have any connectivity with your physical server, physical operating system, if I have to say, with your physical operating system. So this virtual machine will act like an new computer or else new server. So it cannot have all the binaries of the system. It will utilize its own operating system. So in the virtual machine, what we are going to do, we will be installing the operating system. So on the virtual machine, what we are going to do here is we will have the binaries and libraries that belongs to that operating system. For example, if you see the Linux have the different types of binaries and libraries to run the application, it will have certain binaries. So binaries are nothing but the compiled code, whatever the application that you want to run. So the application code that depends on Linux is different when you compare to the Windows. So the point is, so if you are running the virtual machine on your Windows operating system, also you can run the Linux machine separately. So itself it acts like a different mission. Okay, and onto that, what you can do, you can create your binaries or else you can create your application on your own virtual machine. So which means that you don't have any connectivity with your operating system, with your hosted operating system. The application will have the, or else the application will consume the resources from the virtual machine. Eventually the virtual machine is going to communicate with your hardware and it is going to take the hardware resources. Altogether it's a different topic. So here what is happening here, and I can create one more virtual machine, I can run the binaries and I can run my code, everything on that particular virtual machine. So altogether it's a different topic. Now when you come back to the Docker or else when you come back to the containerization, so VM versus containers, if you see the primary differences here, let me show you like this. If you see here, what you are capable to see, or else what you are able to see here, you are having the infrastructure like your hardware, storage, and CPU, and there is an hypervisor. Hypervisor is nothing but your virtualization software. Onto that directly you are installing your virtual machines. Here you will have guest OS one, either it might be Linux. In Linux you can use the Ubuntu OS, and onto that you will have the Ubuntu related binaries and libraries. See, if you want to install anything in the Ubuntu machine, then you will go with the apt command or else apt utility. So that is the binary which you will use in the Ubuntu. So whenever you are having another Linux operating system, that is Red Hat Linux operating system, there you will go for the yum command. Okay, so there is a slight difference. If you want to install NFS, which means network file sharing, it is one of the utility. So here you will use the command apt install nfs-common. But when you come to the Red Hat Linux, for example, if there is another virtual machine where we have installed the Red Hat Linux, then what will be happen there? The binaries will be different. Okay, the binaries is going to be different. And when you come back to the Windows operating operating system, you will have the .exe file. So there will be binaries and libraries will be different for the Windows operating system. Especially if you want to install any software, Windows will support exe files and .msi files. When you go to the Red Hat Linux, it will support .rpm files. When you go to the Ubuntu machine, it will support .deb files, which means that there is a lot of differences between the binaries and libraries. So here the guest, depending on the guest operating system, the binaries and libraries will be changing. So this entire virtual machine will act as an isolated server. Now, when you come back to the containers, nothing but your Docker application, you will have the infrastructure, which is nothing but your CPU, RAM, and storage. Onto that, we need to install an operating system, either it might be Windows or Linux, any operating system we are going to install. And onto that, we are going to use the containerization engine. So what is this containerization engine or container engine? See, when you go to any what I can say shipyard, you can find this Docker. Okay, Docker is nothing but like a let me show you this. So if I have to show, look at here. So this is a very big ship. A simple understanding about Docker analogy with the cargo ship. Here, this is the cargo ship. So if you see here the Docker is looking like a ship. Onto the ship, you are having certain containers. So in the same manner, if you see this is the physical form, like real-time form, real-time example, which I can tell you. Here you can see there is a very big ship. Onto the ship, you are having different types of containers. In these containers, a lot of loads will be there, like textiles will be there, food will be there somewhere. In our country, we will import and export so many different things through these containers on this ship. So here you can see this is the cargo ship where it is carrying multiple containers. So in the same manner, if at all, if these containers need to run this application, if I want to run the application, then definitely I need to have a containerization engine or a container engine like your cargo ship. So this cargo ship is carrying the containers, right? So in the same manner, here also, if you want to run an application inside a container, now what is a container? Here you can see there is a container. Now here this container will have an identification. So if you can see here, every container will have an identification and it will have the ID and related to that application. So here there will be a label. So for each and every container, there will be a label. On the label, what you can see here is what is the ID of the container, which application it is carrying, or else which good it is carrying, like goods, nothing but your textile goods, or else rice good. Rice is also one of the good, and iron ore, like that, which form of goods it is carrying out. That will be there on this container. In the same manner, here also in the Docker, if you come back to the Docker, if you compare the Docker, here also you will have the container which will be carrying the application. In general, a container is a process. So now what is this process? For example, in Windows, if you can see here, there are a lot of processes that are running. Here you can see Zoom meeting is a process, and SQL server is a process which is running. Chrome is a process which is running. So here it is a process. Inside the process, you will have the application. For example, Zoom meeting is an application. Inside that, we will have the applications like video recording, audio recording, like that we will have the application. So here the process is nothing but the application. So inside that, the process is nothing but the core form of your application. Onto the process, you will be running your applications. So now the point is, here all these applications, so whatever you can see, the app 1, app 2, and app 3 on the container engine, they are created inside the containers. Those are the processes. So one container will not have any contact with the another container, which means that there will be, come back to the real-time example, there will be different goods in different containers. One container will not have the same goods. For example, if you take, in the same manner, here also each and every container will have a different application. But if you want to make the communication between the containers, you can do that. That is altogether a different thing, which we will be learning in the Docker networking. But the point here is, when you compare with the virtual machines, here the guest OS, the applications and libraries will be communicating with your guest OS, not with your hosted OS, which means not with your hype, or also what I can say, there won't be any specialized underlying operating system won't be there. So it will have each and every what I can say virtual machine have its own guest OS. But when you come back to the containers here, each and every container will be getting the space, will be running on the process that is related to your operating system. So if you see here how containers, okay, run on Windows, or else what you can see here is how what I can see how containers will work with a single OS. Simply I can go with the hosted operating system. Okay, because the containers share the OS kernel. Once the instance of OS can run many isolated containers, the OS supporting the containers can be smaller and the fewer. Now, if you can see here, now what is a container? What exactly is a container? So how you can run the container? That is here you can see what they are saying here is, look at here. Sorry. So what are the containers? Containers are a type of software, nothing but like your Google Chrome or else like your PowerPoint. It is also a software that can virtually package and isolate the application for deployment. So one application isolation in the sense one application will not have any communication with the another application by defaultly. If you want to make the communication, you can make it. But the point here is container packages an application code and dependencies together, letting the application reliable running in all the computing environments. What is the meaning of this? See, for example, I want to run some Spring Boot application. Okay, I don't know how many members of your developers and see, for example, I want to run an application. So to run any application, what are the requirements? Can you say? What are the requirements to run an application? Can anybody say? For example, if you have a banking application or also any application if you want to run, what are the requirements for that? Anyone? Waiting for your response, guys.
Usually there will be a system where we run our application.
No, I'm not asking about the system. For example, if you want to develop an application, there is a Java application. So for Java application, what will be the dependencies? For example, let me show you one thing. I have an application. I think I can utilize this. Hold on. You will come to know about this hub, Docker hub and everything. Don't worry about that. So yeah, here I have the Python application. See here. Okay. So now Python, what is the tag? KTS. KTS I want a different application. Hold on, guys. KTS Python. Can I use this? Version 1 is there. Or else is there any another thing which I have? Utilities, entry, login, Docker test. Okay, let me go with this Docker batch. For example, this is the Docker batch which I have. Let me go with this. What will be there? V3 version 3 is there. Let me go with this configuration. Voila. Okay, okay. It is just a label. That's it. Okay, fine. Now coming back to this, for example, I have an application. Okay, so if I want to run that application, how I can run the application? What are the dependencies? Every application will have a dependency. Okay, every application will have its own dependency and how we are going to run that or else how we are going to create that application. For example, there is a Java application. Oh, so this is voting app is there. Okay, there is an voting application and this voting application, for example, so this voting application backend, we have several things to run. So if you want to get this in the front end, you can simply access this website. This is the UI part. Whatever you are seeing here, aws.amazon, this is the UI part. You can get it very easily. But my consideration here is what exactly will be there in the backend. So see here, there will be a voting application. If you want to vote, this voting application will be transmitting the data to the Redis, and Redis will communicate with the worker, which is created in the .NET framework, which means in the .NET application. So try to understand, with the .NET coding, they have created an application. So this application is mainly necessary for you. It's like a backbone for your entire front end and the database. So which data should be forwarded to the database and which data should be fetched out from the database, everything will be given by this worker. So this is the main important application. And this application is running on .NET. So here the point is, now for this .NET, what will be the dependencies? For example, if there is an application, let me tell you, for example, we will create application for the bank sectors. For banking sectors in our company, we will create the applications. Okay, like whatever the Paytm application that you are using, like that is called as digital banking. And for example, if you are going for onboarding in the sense, for example, you are a new customer, so you want to use the what I can say, internet banking, then how you are going to create it? For that, like we are going to create some application for the users. So we will work in the banking sectors. Now for this, what we will do here is we will create the apps in Java. Actually, we will use the Java coding for create this application. So to create these applications, we need to have some dependencies. So like we need to have Java 8 version only. So we have to use Java 8 to create this application. This is the fundamental thing which is given to us. And then we have to create some Spring Boot application. Okay, so we have to use the Spring Boot application to create the applications, whatever you are seeing here. So Spring Boot coding we have to use. So everything like this. So we have certain dependencies. So now what is coming back to our container terminology? Now what is a container? So this container will have all these applications, whatever the dependencies that just now I have said to you, all these applications will be there in the, what I can say, in your container. So what you will have, you don't have only the application code, you will have the, what I can say, dependencies and whatever the requirements to run that particular application code, all are available inside your container. So that is called as a container. So how a container will be created? A container is not simply a process. It will have all the dependencies and the executable code will be there. Executable code in the sense, whatever the front end and whatever the applications that you are running, each and every code will be there inside the container. So that is called as a container. Understood about this? Any questions? Any confusions over here? Do you understand what is meant by a container?
Yeah.
Are you sure? I cannot hear that excitement. Is it clear from my end? Any questions, guys? Don't feel so if I ask this question, our faculty or also our trainer will hesitate to answer. There is nothing like that. You are just learning, so it is not a thing like whether I have to ask this question or not. So you can ask any question. I will try to provide the response for you. If you have any doubts, please ask me. And again, when you go back to the interview, don't say me that, so my sir didn't said me this. Don't say me that. So I'm requesting you, if you have any further questions, you can ask me now. Is it clear from my end? Okay. So when I come back to the next concept, so see here, containers share access to an operating system kernel without traditional need for the virtual machine. So what I said here in the environment, whatever the example that I took over here you can clearly see this. You see, whatever the application, whatever the example here, or else whatever the diagram you can see here, this applications will be communicating with your like operating system. These binaries will have each and every operating system. They will communicate with that. But now here, all the binaries, you can run one container with the Ubuntu operating system. You can run the another container with a different type of operating system. So the underlyingly, what is going to happen here is, so container access an operating system kernel without traditional need for virtual machine. Can anybody say what is meant by kernel? So what is meant by kernel? Any idea about this? You know about operating system.
Operating system.
Sorry. Come again. I'm unable to hear you. Sorry about that.
Heart of OS running system.
It is a heart of operating system. Very well said. But let me frame it in a different manner. For example, there is a user. Okay, there is a user. I am there. So I want to execute certain code. For example, in mathematics. For example, I will go with 172 plus 16. So it is giving me 188. Okay, this is an application. So here, first thing what I'm doing, the user wants to open an application. How he will open the application? Directly, if I say to the computer open the calculator. Of course, nowadays you can get the voice recognition also, but that is altogether a different one. So if I communicate with that also, so user is communicating something directly. He is not communicating with the hardware. To understand this, directly he is not able to communicate with the hardware. Why? Because the hardware language is, what is the hardware language? Computer language.
Machine language.
That is what? Ones and zeros, binaries. So the hardware can only understand binary language only, ones and zeros only. It cannot understand the human language. If I say, hey computer, how are you? It won't understand. So it has to convert it into its understandable language. Now the problem is, now the user is trying to communicate with the hardware to open an application, but he cannot open that. Why? Because user doesn't know the binary language, ones and zeros language, he doesn't know. And computer doesn't understand the user language. What he is using, computer doesn't know about the user language. Now who has to interpret this? If I have to say, for example, PM has visited to our state. Right now I am residing in Hyderabad. So PM Narendra Modi has India PM Narendra Modi has attended for an what I can say, very huge venue. Okay, so he is trying to talk something. So he will continuously talk in Hindi, and the people who are residing in Telangana, they only know Telugu, for example, understand, they only know Telugu. Now who will make them understand about what he is saying? So in between the president and the people, for example, take this hardware as a president and the people as the users, in between people and the prime minister or president, you will have a translator who will help you to make the communication. In the same manner, here between the user and your hardware, you will have an operating system. Sir, you are saying very slow, very low level. Of course, I understand that. Yeah, you need to get this point. So there will be an operating system. So whether operating system will convert the user understandable language into the binary language? No, it cannot do that. Now here the operating system will assign the task for the kernel. So kernel is very important for any operating system. Without kernel, the operating system won't work. The application inside the operating system won't work. So that much important is kernel. Like heart, as our fellow friend has said me about this, it is like a heart of operating system. In the same manner, so kernel is like a heart of your operating system. So whatever the user requirements are there, the OS will communicate everything to the kernel. So what kernel will do? Kernel will do the compiling. Compiling will be done by kernel. Not only compiling, it will do so many things. So compiling actually done by binaries. That's altogether a different format. So what kernel will do? Now, if the user requests to open an application, so at what time it should be opened. At what time it should be processed? See here, still the VMware application is not open. So why it is taking some time? Because of my processor and all the things. You will think first, like for example, now what happens here is when the user requests any data from the operating system, the operating system will communicate the same to the kernel. So now what kernel has to do? Kernel has to do certain tasks. So the work of kernel is it has to do memory management. Memory management in the sense RAM management. Okay. Processor management. At what time the processor has to execute the code. So how much amount of data should be stored in the RAM and what should be displayed, what should be communicated with the user. So everything, each and everything management will be done by your kernel. So that is the importance of your kernel. So if at all, if the user wants to communicate with the hardware, of course it might be like operating system might be an interpreter, but operating system itself will communicate with the kernel and the kernel will do the translation and do the resource management. Okay, so resource management in the sense processor management, memory management, storage management, power management, everything will be done by your kernel. So without kernel your operating system won't be working. So now when I get back to this, containers share access to an operating system kernel. So now how containers will communicate? So I said you that, so containers is a lightweighted virtual machines where it doesn't have any sort of guest OS. It will use the operating system of your, what I can say, your computer or else your server. So on which operating system the Docker is implemented. So the containers will use the operating system kernel. So now what is the main functionality of the kernel? When a container runs, so it should allocate certain memory. Who will allocate that? Obviously kernel will allocate that. It should allocate some processing speed, processor. So that can be done by kernel. So my container will directly communicate with the kernel and kernel will provide whatever the necessary things for the for the containers. So, but when you come back to the virtual machines over here, the application will communicate with the guest OS and guest OS has to communicate with the infrastructure. That is altogether a different thing. Now here in the containers are directly able to communicate with the operating system kernel and kernel will provide whatever it is required for the containers. This make them very lightweight. Here we need to have an guest operating system, but here we don't need any guest operating system. Directly it can communicate with the host operating system. Here we have two new words. What is that? Host OS and guest OS. Host OS is nothing but the operating system which is directly installed on your computer. Okay, OS which is installed on OS which is installed on computer as a host operating system, and guest operating system is the OS which is installed on the VMs. So VMs will have the, each and every VM have the different guest OS. Now that is the main difference. So it doesn't have any new the containers will not have a new operating system. It will use the host operating system itself. So these containers are lightweight in the sense we are not going to carry it, but for transmission from one server to the another server, they are not going to consume heavy space like 30 GB, 40 GB like your virtual machine. They will be around some 500 GB, sorry, 500 MB or 100 MB. That much small size of containers will be there. So you can run the application anywhere. So that is the main importance with the containers. If you see here, containers share the access with an operating system. That's okay. Containers can be used to run small microservices, larger applications, or even lightweight containers. Okay, so we can run the multiple microservices. Here there is a question, what is a microservice? Can anybody tell me what is a microservice? Here you have a word called as microservice. But before we go with this microservices, eventually you are going to learn about the microservices in the Kubernetes. Don't worry about that. But before I go into the further topic, Anybody having any questions? Am I clear with this concept? Any questions for you?
Yes, sir. You are showing the applications using Java, sir. Java only Spring Boot like that. This Docker application. I mean, this.
No, I'm not going to show Java.
Oh, no, no,
I
sir.
said that
You are
I am
deploying like
working
this.
on the. No, I'm not going to deploy the Java and the Spring Boot applications. Okay, so this is just for your understanding. I'm saying. So how we are going to run that and how we are going to manage, I will show in the later on sessions. I'm not going to use. I'm just going to use the sample applications. That's it.
Okay,
Okay.
sir. Okay, that's fine. Yeah.
Any another questions? So I hope that you understand this clearly. What is a container? What is the difference between Docker and a container? Any questions, guys? Fine. Now, what is meant by a microservice? Can anybody explain me what is meant by a microservice? What is a microservice? Now, let me show you something. You know about this application, right? So this is an application. What you will have inside this application? Can anybody tell me what you will have inside this Paytm application? So everyone are using, right now everything is digitalized. So everyone are using Phone Pay, Paytm, Google Pay. So you are using like that. So now what you will have inside this Paytm application, or also you can go with the Google. Yeah, go on.
Small services, sir, like a Paytm for consumer, like different functionalities.
Exactly. So this is a very big application. Whatever the Paytm application that you are seeing here, if you click on sign in, a service will be opened. So how you can sign into this account? So this is a service. And when you want to travel somewhere else, you can go for the bus tickets. This is another service. And if you go for these are all the small services. When you want to go to the train tickets, it will be redirecting to the train tickets application. If you want to go to movie tickets, it will be. So these are all the small services, nothing but the micro services which collaboratively makes an application. So which combinedly makes this Paytm application. Now, for example, if I go with the Netflix also, this is the famous OTT platform where you can go to. When you go to the Netflix, here you will have multiple things to do. So I can go with somewhere like what I can say, web series or also movies. There are a lot of things in the Netflix also. So these are all the microservices. So all the services are combinedly forming an application. Now each and every service won't be in a single server. So you think that all the services are running in a single container or else running on a single server. That is not happening. So each and every service will have another separate container. So if you see this recharge and pay, electricity bill, these are the two services. And if you go to the bus tickets and flight tickets, these are the different type of services. They will be in the different containers. Each container will host one type of service. Now, by combining all the containers, we are going to create this Paytm application. In the same manner, here also they are saying the same. If you see here, so what they are saying, containers can be used to run small microservices. So whatever the small applications, small services that are there inside your application. For example, if I go to the ICICIbank.com, here also this is a very big application which we are running. But inside this, we are having the accounts. This is nothing but onboarding. We are having the deposit. This is another service. We are having cards, credit card and debit cards. These are the another type of services, loans, investments, insurance. These are all the different small services which collaboratively makes a application. So now the point what you need to understand here is this is not so. If you see here, there are two types of services. One is monolithic service. Again, if I go very in deep into this, then you will get some confusion. Monolithic. So now what is meant by monolithic application or monolithic service? In the sense, everything is integrated in the same code. So if whenever I'm developing this particular application, so I will integrate the accounts, deposit, payments, everything will be in the same code only. Try to understand, everything will be in the same code. For example, if I have to say in the childhood you will learn some subjects like Telugu or else your native mother tongue language, Hindi, mathematics, science, social, and so there are some subjects are there, right? Now the point is each and every subject is different. For example, if I am going to conduct an exam where all the subjects I am collaborating to each other, or else where all the subjects at a time, then that will be very difficult for you. If I say that you are having only one exam where you will have Hindi, English, mathematics, science, and social, it's everything is collaborative into a single exam, and you need to pass with 35 marks, then that will be a difficult task. Why? Because you have to learn each and everything for you. So if there is a small mistake in it, for a small mistake, or else let me take another example like that. You can have another so many example. If at all, if you are having a very big application where you are running multiple services and all the services are integrated in a single platform or a single application, if one service is down, for example, if this loan service is due to any reason, this loan service is down, then total application will be down. So you cannot have all the services in a single application. Now what they have done, what the IT people has done here is they divided each and every service into a different application. So that is called as a microservice. If one service is down, for example, if this loan service is down, it is not going to impact on your entire application. It will be impacting only that loan service, and if on the remaining services will be running as usual. So here the problem won't be there for the entire application, it will be there only for this loans application. But what is the main difficulty with this microservices is that, so if the number of services are increased, then the application will be, or else application code will be increased humongously. Okay, it will be very high. So that's the main problem with the microservices. Anyways, so again, coming back to this, so each and every container can run its own microservice. So that's about your containers. So again, they are telling you about the container technology and all the things. Now we are going to use the Docker as the engine, and it's very popular now. Why it is very popular? Why Docker is very popular? Because it's a freeware, and so it's very easy to install. Also, Docker is very easy to install and very easy to run, and everything you will learn in the upcoming sessions. So that's about your containers versus virtual machines. In the next session, we are going to learn about the in-depth analysis of Docker, how to install the Docker on an Windows operating system, or else how to install the Docker in an Ubuntu operating system, and then we can go ahead with the Docker configuration from Monday. So tomorrow will be the last demo session for you guys, and from Monday onwards, you will have the normal Docker classes. Okay. So that's all from my end. If you have any further questions, you can ask me now. And the course duration will be 30 days. Again, coming back to this, course duration will be 30 days. You will have the video recordings every day. You will get a video recording. And course fee will be 5,000 rupees. Don't bargain it. Again, coming back to this. Okay, it's just a 5,000 rupees of course fees. And what else I can say? You can go to the DURGASOFT.com, where you can find the syllabus, or else whenever I'm dealing with the Docker, there I will tell you about the syllabus. Don't worry about that. So this is what I want to say you. Any questions from your end, you can ask me.
Sir, totally
Question, guys.
30 days, sir. Completely, it will be completed within 30 days, sir. Completely Kubernetes and Docker completely.
Yes, Docker and Kubernetes will be completed in 30 days without any weekends. There is no weekend holiday for you. Except
even Sunday.
Even Saturday and Sunday also you will have the sessions.
Okay, sir. Even Saturday and Sunday also.
Yeah. See, anyways, you are investing only 30 days of your time. So just 4 weeks, you won't have like one and a half hour. You won't have your what I can say weekend celebrations. After one and a half hour, you can do your celebrations. Okay.
Yes, sir. And any are you planning to take any morning sessions, sir? Any?
Right now it is not in the schedule. Why? Because see, in the early hours we will have the deployments, we will have the production deployments. That too, we are working with the South Africa clients. Wherever I am working right now, the company is related to African clients, so we have to deploy the applications in the early hours. So I'm not planning any morning sessions, But if there are any morning sessions, but as per my timing schedule, I don't think within 3 months it is not going to happen. If you are very interested, that's only 1 hour, right? So you can join at
Yes, sir. Yes, sir.
7 o'clock.
Actually, what happening while working also sometimes problem na office work and suddenly they are pinging and like that. That is a problem.
I can correlate to that. Why? Because I have to attend some production.
Yeah. Yes, sir.
But this will be convenient time for me, so that without any fail I can go ahead. But I can say you one thing, sometimes I might have to include in the production call at 7 o'clock 7 p.m, but sometimes, rarely in the evening times, but clearly in the morning times I have to attend the sessions. So that's the reason I'm saying it.
Okay, sir. Okay. And even 8 to 9 also batch, sir. After this batch, 8 to 9 also you're going to take.
There is no 8 to 9 batch, only 7 to 8 batch is there. And there will be an 8 to 9 batch, but that will be merged into this 7 o'clock batch only.
Okay, sir. Okay. Okay, sir. Got it. Thank you.
Yes, chalo. Then we will meet tomorrow and we'll discuss in deep analysis of Docker. So, hi, and we'll meet in another session, guys. Bye.
Thank you. Bye.